Hey, hello everyone. So today we'll be looking at the leaderboard problem, longest palindromic substring, a very frequently asked question and definitely something that you should solve once before the interviews. So when you look at the question, it basically says, given a string, we'll have to find a palindrome within the string. It has to be a substring, so a contiguous sequence of elements within that string. And since it's a palindrome, whether you look it from the left to right or right to left, the sequence of characters in that should be the same. If you look at the constraints, the string can be up to a length of 1000 characters and it contains only of digits and English letters. So to think of a brute force approach for this problem, so let's say we have this string B A D. If we are looking for a brute force solution, in the first pass, we'll have to uh, look at the beginning character of the substrings. So, for example, one sequence can be B A, one sequence will be A B A D, and another sequence would be, okay, this is maybe not the correct way, just give me a moment. Yeah, so let me phrase it this way. So the starting sequence, the starting character of the one of the possible substrings will be the one starting with B, then the one starting with A, the one starting with B, and the one starting with A, and the one starting with D. So this will be our first loop with which basically says the starting index of substrings. Then again, in the second loop, we will be building all the substrings. For example, we'll be building BA, then BAB, then BABA, and BABAD finally. So second loop build substrings, and then the final loop we will be checking for palindromic substring property. So again, for this step, uh, I wouldn't say it's a third loop, but one more order of n iteration to check for palindromic substring property. So if you look at a high level, it translates to an order of nq time complexity solution where n is the length of the string. N is the length of the string. So can we do something better? Definitely. That's what we are will be looking at next. We'll try for a dynamic programming solution. So when you look at our function, we see that we are working with substrings. And can we have a function like dp of start and dp of end, where basically this dp of start and end gives us the longest palindromic substring for substrings starting with index start and ending with index end. So for example, if we have the string BABAD and we are looking for dp of 0, it will obviously be always a string of length 1. So it can be B in this case, dp of 0 to 0, where both starting and ending index are the same. Alternately, let's say if we are looking at dp of 1 and 3, so for this we can see that. ABA is a valid palindromic substring, so it will be ABA. Similarly, if we are looking at DP of 0 and 4, this will give us our answer. So it can be BAB or ABA. Yeah. So DP of the index starting at 0 and the index ending at the length, the total length of the string minus 1, which is 4 in this case, would give us the final answer. So we can see this is like a two-dimensional dynamic programming problem. Yeah, so we have identified the function. In the next step, we'll be identifying the base condition. So if we look at this, okay, I think we should first move with the recurrence relation, then we can move on to the base condition identification. So if we look at the recurrence relation, when we are at dp of start and end, there can be two possibilities. So dp of start and end is a palindromic substring, and then it is not. So if it's a palindromic substring, then dp of, let me just say s and e, dp of s and e is equal to the length, I mean dp of s and e will be nothing but the string starting with s and ending at e, right? But if it's not a palindromic substring, then dp of s and e is max of dp of s plus 1 and e, or dp of s and e minus 1. So let me try to this part, explain this part. So I think palindromic substring dp of s and e, when it's a substring itself, this should be clear enough. For example, when we are looking at the string, so yeah, so example, when we are looking at the string BABT and when you're looking for dp of 0 comma 2, we see that the string in question is BAB, and is BAB a palindromic substring? Yes, so we can directly put the substring as B and B, BAB. So as the string starting with index S and ending with index E. Now moving to the not palindromic substring case. So for example, we are, let's say, looking for the sequence dp of 0 comma 3, this part. Yeah. So as you can see, BABA is not a palindrome, right? Is not a palindromic substring. So what are the next sequences or substrings that we can explore to check for palindromic substring property? So we definitely know BABA is not a palindromic substring. So what essentially we can do to see if other substrings inside this are a palindrome or not, we can move the start pointer by 1 point and check for ABA. Similarly, we can move the end pointer by subtracting 1 to it back, one step back, and we can check for BAB. Similarly, in the next step here, we'll be checking for the string BA and AB. Similarly here, we'll be checking for the string BA, sorry, AB and BA. It will continue till we are going all the way to A, B. Yeah. So if you look at here, we are solving a lot of uh, repeated problems, right? So what you call basically the overlapping subproblem. So here we are trying to check if A is a palindromic substring, B here, and again we are trying to check these repeatedly, even when you look at BA and BA here. So that's how dynamic programming helps us to um, avoid duplicate computation of overlapping subproblems. And again, when we look at the optimal substructure property, like if A is a palindrome, right? When we look at the substring BA, then even inside this A continues to be a palindrome, and yeah. So finally, we will look at the base condition. For the base condition, when start is greater than end, we can say the palindromic substring is an empty string. Yeah. And we can basically stop the iteration. So basically, yeah, we don't need to even set an empty string. We can just go ahead and stop the future iterations. Now we'll try to solve the problem. Yeah, let me clear the screen. Okay, so as we saw, we need a two-dimensional array to store the dp function. Even before that, we can start with this simple check. If the string is a string of length equals 1, you just return the string. Now let's start with our two-dimensional array to store the results. Done. Now we will define a solve function to basically solve the problem for us. So let me define function solve, and for this we will first take the dp array, and we will also take the string, and we will take the starting index and the ending index, and we are going to return the dp start and end. Yeah. So basically, this would help us to store these values for this case especially. Yeah, so the function should return the dp of the string starting at the index s and ending at the index e. So the return type would be a string. And let me also set the parameters here correctly. Always we will start with the 0th index and we'll be ending at the last index. So as we discussed, to our solution would be the string starting at the 0th index and ending at the last index. So now let's solve the problem. So First of all, as per the base condition, if start is greater than end, we can simply just a moment. If start is greater than, and we can simply choose to return an empty array and break off. So since we are as we had noticed, there are repeated sub problems. If dp of start and end is already solved, we don't need to solve it again. So we can just return the pre-computed value. Now, looking at the first condition, if s dot char at start equals s dot char at end, this says that the current stream is a palindrome, but to check for complete palindromicity, we would need to check the other elements in the sequence too. So s start plus 1 comma n minus 1. Let's implement our function for checking palindromicity. Now we will look at the other case where the current substring is not a palindrome. So as we had discussed earlier, we will be using this recurrence relation. dp of se is equal to max of dp of s plus 1e and dp of se minus 1. So let's solve the index. Let's solve the string starting from start plus 1. Let's call, so it will be dp given by solve dp of s start plus 1 and then string of n minus 1 will be solve s start n minus 1, then dp of start and end will be max of Just try running this. Missed a bracket here. Oh, I declared it as a integer array instead of a string. So somewhere we are crossing the threshold of the end string. So let me check where we could be making this mistake. So we have declared this is the mistake. Should be the length of the string should be the length of the array which should be the length of the string. Okay, it's returning an empty string. This looks good. So we are always returning an empty string. Let us go through one by one. Here start solving for the entire string. Then at the first step we're checking for the base condition. And dot caret start equals n and let's start to solve dpfs. Start plus 1 dot length greater than minus 1 dot length. Hmm. Let's see if it reaches this step. It does. We get AB and BAB, so why is it not able to store it in the result? Hmm. This is where I missed the step. Should be returning here instead of continuing execution. And yeah, so as you see, the question is solved.